I always struggle with the very beginning of these. Okay, all right. Hello, everyone. My name is Paul. I'm Paul with Tutor U, and today we're going to be going over one variable and two variable linear equations. A lot of people struggle with solving these types of equations, and they do show up on the GED quite often. A lot of the main parts of the GED will include your one variable and two variable equations. So what we're going to do today, just always make sure you take it easy. Don't get overly excited or overly stressed when it comes to math. You always want to go nice and slow. So if you are on my side of the planet in the United States or anywhere, make sure it's early in the morning, but whatever time you watch this, have your coffee ready. I certainly have mine. Have your coffee ready, relax. We're just going to go through and talk a little bit about one variable and two variable equations, and I hope that you learn a little bit along the way. So let's get started with the class today. Let me just go switch over and bam. Okay, so look at that. I have my own little chalkboard here. The way that class is going to operate is I have already pre-set up a bunch of different slides going through the definitions, and we are going to go through one word problem today. Don't let that overexcite you. I know everybody loves word problems, but it's just going to be nice and relaxing. When we go through definitions, I'm going to go through each one and try to kind of translate them or make them a little bit more easier to understand. So let's get started on the first definition. So remember, we're starting off with one variable linear equations. So how to work with them, how to solve them. Once we go through all of the definitions, then we're going to go through example problems. So, okay, a lot of words just showed up on the screen, I know. But let me go through this. So one variable linear equation is an equation that consists of expressions involving only number values and products of constants and a variable. Okay, so let's just kind of try to translate what is happening there. The very first part I want you to kind of think of, so it is, hang on, there we go. It's expressions involving only number values and products of constants. Okay, so what does that mean? What is the real life translation of an expression involving only number values and products of constants? So I'll just write one out here. So we have 3x plus 4 equals 16. All right, so this right here is your expression, right? And inside of this expression, we have a constant 3 being multiplied, or the product of 3 and x. So the 3 is being multiplied by the x. And then we have the number 4. So this is an expression involving only number values and products of constants, okay? When you have division, technically division is a product of a constant, so we don't need to get into the technicalities there, but division is okay. It is still a one variable linear equation, and that's the definition. So what I would recommend is if you are taking notes, or if you don't have the ability to take notes, take a screenshot if you're watching from your phone or whatever device that you are watching on. Otherwise, I would strongly encourage you to take notes, because that's going to help with retention, right? That's going to help you remember all of these different things. So it is the one variable linear equation. It is an equation that consists of expressions involving only number values and products of constants and a variable. We have our variable right there. Let's just make a little note of that. This is our variable. Let's make it green. Our variable. And our constants 3, 4, 16, and then you have multiplication occurring between the 3 and the x. Not too bad, right? It's just nice, plain and simple. But the common thing that you're going to run into is they're going to ask you to solve equations, right? And a lot of people are like, well, how do I even go about, how do I start solving an equation? It's through a process called inverse operations. So let's go through and define inverse operations. Inverse operations, the way to isolate the variable, the way to get the letter by itself. It's also the way to solve the equation. All right. What I have up here, we have operations and the inverse of those operations. That little arrow in the middle, double-sided arrow, that means that it can work both ways. So the operation of addition, your plus sign there, the inverse operation of addition is subtraction. Multiplication, the inverse operation of multiplication is division. And then you have an exponent, which we're not going to deal with today, don't worry about it, but the inverse, the inverse of your exponent, or taking something to the power of something, is to root it, right, over on the other side. And then I have that little note of the square root of x squared equals x. If you notice, they cancel each other out, right? So whenever you perform an inverse operation, it cancels out the operation. So if you have 3 and you minus 3, right, it's going to get rid of it. It's going to go to 0. If you have 2 and you divide by 2, it's going to get rid of it in a certain way. It's going to change it into a 1, so it doesn't really matter anymore, right? So like we can kind of ignore ones, or they're called implied ones. They exist, but we don't need to write them down. You'll see this today. And then lastly, your x squared just completely cancels it out when you take the square root of something. That works for any power though, right? So let's say x cubed, the inverse of x cubed, so x cubed is x to the third power. The inverse of x cubed would be the cube root, okay? So let's move on. I know the isolate just means to get by itself, but this is how you solve equations. I think this will become much easier to understand when we work through example problems, which we're going to start doing example problems right now. That's all of the definitions for your one variable linear equations. Not too bad. So this is your typical question when it comes to one variable linear equations. It is, what value of x makes the equation true? Another way of asking, solve the equation, okay? So our equation is 3x plus 9 equals 6. 3x plus 9 equals 6. And I'll take this time right now, before we do this example, to where if you're watching this, if you are planning on, taking advantage of these online math classes, I do these online math classes on YouTube Monday through Friday at 9 a.m. Central Time, and I also have a whole library of videos that's starting to get built up. So if you need extra help, you can get that extra help through my videos. And please like, comment, and subscribe. It will help grow my channel, and I'll be able to help more people, right? So the more you are active on my videos and on my channel, the more it spreads it around to other people, and that just means that more people can get help with their math and with the GED math, okay? So let's go ahead and find what value of x makes this equation true. Now, we have 3x plus 9 equals 6. So I already told you we have to do inverse operations to isolate the variable. So what is the first item we want to get rid of? Think of it like we want to start farther away from our variable. So we have our 3x plus 9. We have our plus 9, and we can get rid of that by the inverse operation of minus 9. So all we have to do is, oh my goodness, I'm so sorry. There we go. is subtract 9. Now that equal sign, right? The equal sign means that we have to maintain equality, right? Whatever is true on one side is also perfectly true on the other. They are equal on both sides of that equal sign, right? So whatever we do to one side of the equal sign, we must do to the other side of the equal sign. So since I am subtracting 9 on the left side, we must subtract 9 on the right side. So I'm just going to go ahead and write minus 9 on the right side. Now, what happens, so we're going to just go through and simplify this problem down. So what happens when we subtract these 9s? Well, it cancels out, right? It cancels out into a 0. We don't need to write that 0 though, because 3x plus 0, that's meaningless, right? I'm just saying plus nothing, so we don't need to write that down. Over here, we have 6 minus 9. That is something, but I'm going to start writing my problem down before we do that operation. So we have 3, oops, let's change that to white. We have 3x equaling, because that 9 and negative 9 cancel each other out. We have 3x equaling, so what is 6 minus 9? 6 minus 9, so you have $6, and I'm coming up to you and I'm saying, you owe me $9. What do? You only have $6 in your pocket. Well, you give me your $6 and you still owe me $3. So you're $3 in the hole. Not a good position to be in. But the way to represent that mathematically is -3. So our new equation is 3x equals -3. Now, what's occurring, what's happening between the 3 and the x? It's multiplication. You have that constant, your coefficient, in front of the variable, and so 3 times x. So what's the inverse operation of 3x? What's the opposite of multiplying by 3? Well, it is dividing by 3. And the same thing here, the way that you maintain equality is you must do it to the other side of the equal sign. So we divide by 3 on this side. Now, what happens between these 3's? This one goes down to a +1. We don't need to write that again, right? Just for the sake of neatness, I'm going to move over here. So it's x equals, and what is -3 divided by 3? Your -3 divided by 3, well, 3 divided by 3 is 1, but over here on the right side, we have this -3. So what happens when you divide a -3 by 3? You have a -1. And that is the value of x that makes this equation true. So if we were to take that and plug it back into our original problem, right? So 3, and then instead of writing the x, we put a -1 plus 9. Does that equal 6? Yeah, 3 times a -1 is a -3 plus 9. Does that equal a -6? Yeah, -3 plus 9 is 6 equals 6. This is true. So we've successfully solved this question. We've figured out the answer to it. Not too bad, right? That's a multi-step, one variable. There's only one variable linear equation. Okay. But I don't want to just do that and then stop doing it. So let's move on. We're going to do several examples, and we're going to do a word problem with a one variable linear equation. Now we have our next question. And the thing here I want you to kind of make a mental note of is how the wording of the question has changed. Before, they were asking you to find the number that makes the statement true, right? In this question, all they're asking you is solve the equation for x. It basically means the same thing, right? When I ask you to find the number that makes the equation true, I'm asking you to solve the equation. So don't get hung up on the wording of the questions, but they will ask you different ways to solve an equation. And I don't want you to get those wrong just because of the wording. The other thing I'm sure some of you might have noticed is that we have our decimal, right? People really will try to do anything to avoid decimals, but we're just going to attack it head on, and we're going to figure this problem out. So just like before, we have to do inverse operations. So we have 0.5x minus 4, and that equals 12. When you're doing those inverse operations, your goal is to get that x by itself. So we're going to start a little bit farther away. It's like the opposite of PEMDAS, right? Your please excuse my dear Aunt Sally, your order of operations. It's the opposite of order of operations in a way. What we're going to do is we're going to get rid of the minus 4. So what is the inverse operation, the backwards operation of a minus 4? It is a plus 4. So we're going to do plus 4. And just like the other example, we have to do it to both sides. So we're going to do a plus 4 over here. And our minus 4 and plus 4 cancel out. We're going to rewrite the problem down below. And I really strongly encourage you to write everything out with math. It makes it so much easier to write everything out, right? So 0.5x, and that equals what is 12 plus 4? That is 16. Not too bad, right? So this is where people might get a little bit afraid. What is the inverse operation of what's happening here? You have 0.5 and an x. It's still your constant. It's still your coefficient. So it's being multiplied by the x. So what we must do is divide by 0.5. Okay? And then whatever we do to one side of the equal sign, we must do to the opposite side, the other side. So we divide by 0.5 over here. This side, this left side, pretty easy to deal with. That cancels down into a 1. It simplifies down into a 1. Anything divided by anything, right? So x divided by x equals 1. But when x is not equal to 0, you can't do that, okay? But over here, this drops down into a 1. And we have x equals, what is 16 divided by 0.5? What is 16 divided by 0.5? It is 32. Why do I know that? What's another way of thinking of 0.5? It's half of 1. It is 1/2, right? When you divide 16 by 1/2, what you're actually doing is 16 times 2. That's all it is. So it doesn't matter what number you have when you are dividing by 0.5, you're actually just multiplying by 2. Not too bad. I hope this helps out a little bit. Always remember, if you're doing anything with handwritten tests or handwritten homework, to circle your answers. Your math teachers will love you so much more if you circle your answers, because then it doesn't matter how messy you are, they can find your answer, and if they need to check your work, they'll face that battle when they get to it. But circling your answers is very, very useful. Let's move on to another example problem. I'm hitting you with tons of examples because it's really good just to see it, right? To see it, and then after a little while, you will start to pick these things up on how to solve them. We have another way of wording the same type of question. So what value of y makes the equation true? 5y plus 6 equals 3y minus 14. This is a little bit different of a one variable linear equation, right? You might be saying, Paul, there are two y's. Why are there two y's? Like, people freak out over this, but I promise you, it's not scary. We have two y's, but what is the variable? It's still y. So technically we still have one variable. What we have to do in this problem, right? Same thing, same process, different wording, but the same process. We must move or combine the like terms. We have to combine our variables, like our y's. We have to put them next to each other. So what we're going to do first is move the 3y from this right side over to the left side. So I want to first kind of give us a little bit more space. I'm kind of noticing this is going to get a little bit messy. So let's give us a little bit more room to work with. It doesn't have to be too much more room. And we will get rid of this top part. Oh, nope. And actually, here, I have a different way. There we go. Okay. Now I'll move that back up and we'll have enough room to work on the problem. And okay. So now let's get ready. Let's solve this problem. And how are we going to move this positive 3y over to the other side? It's not through division this time. We're moving the whole 3 and the y. We're moving the whole coefficient, or the whole expression, over to the other side. So what we do is we subtract 3y from the right side, and whatever we do to the right side, we must do to the left, and vice versa. Equality means equal on both sides, right? So we minus the 3y from the left side. And so what is 5y minus 3y? How many y's do you have left? That is 2y plus, bring everything else down, 6 equals, and what happens to our 3y and our minus 3y? That falls off into a 0, okay? And then just make sure that you're bringing the entire minus 14 down with you, right? So we have a negative 14, and we have our new equation. Now we're back into comfortable zone. It's 2y plus 6 equals a negative 14. How do we get rid of the plus 6? We subtract 6 from both sides, and the 6 and minus 6 cancel out. We are left with 2y equals negative 20. And how do we get rid of that 2 in front of our y? Yeah, we divide 2 on the left side. We divide it by 2, and whatever you do to the left side, you do to the right side. I've had prior students that will still, say to me, it's like, yep, whatever you do to one side, you have to do to the other side. You have to get that burned into your memory when you are working with any type of equation. So I will always repeat myself on that. So we have negative 20 divided by 2. Our 2's cancel down. They simplify down into a 1. We are then left with, I'll write it up here, so we're left with y on the left side, and that equals, what is negative 20 divided by 2? That is a negative 10. Negative 20 divided by 2 is a negative 10. 20 divided by 2 is 10, right? The negative sign sticks around. We're good. It's a-okay. The negative sign sticks around in this scenario, right? Circle your answer, and this problem is done. Not too bad. All right. One more regular example, and then we're going to go into a word problem. I'm just trying to get you mentally prepared to see a math word problem this morning, and it can really be a lot. Let's see. Hey, okay, so I have 2 people watching right now, so that's awesome. Thank you. I appreciate you for watching. If you haven't already, make sure you hit the like button. It will help spread this video and more people can learn a little bit more about math, whether you're taking the GED or not. It'll just help spread the knowledge. Whew, my coffee is still very hot. Okay. Now, we will move on. Oh, not that one. We'll move on to our last normal one variable linear equation. Then we'll move on to our bigger word problem. So here it just says solve the equation for x. We've had all different types of wordings, and I hope you're kind of understanding that like there is a group of words, but they're all telling you to just solve the equation, right? Figure out what x or what the letter is, what your variable is. So we have 1/2 x plus 8 equals 5/2 x minus 10. Let that sink in. Let yourself kind of get prepared, mentally prepared for dealing with fractions, right? So we're going to do a linear equation that involves fractions. Everybody's favorite. I would say overall people spend entirely too much time worrying about fractions. When it comes to the GED, some level of fraction knowledge will help you, but there are other concepts that are incredibly important to get down, so don't spend all of your time on fractions, and this will be a nice small bit of practice. So just like before, what I'm going to do is I'm going to erase our words up there just to give us a little bit more space. So let's go ahead and get that out of our way. There we go. And we'll move that up. Space and kind of like some level of neatness is incredibly important when taking notes, when writing anything down. So always give yourself enough room to work and to show your work, right? That's incredibly important. So let's see. Okay, so we have 1/2 x plus 8, and that equals 5/2 x minus 10. Okay, this should seem a little bit familiar though. We have the same variable on both sides of the equal sign, right? So what we want to do is move one of these over to the other side. I suggest you always want your end result to have a positive coefficient. So what does that mean? It means when you subtract or add them over, you want your end result to be positive, right? So you want to move the smaller expression. So which one is smaller? Is 1/2 x smaller than 5/2 x? Yeah, it is. So we're going to subtract 1/2 x from the left side, and then we're going to subtract 1/2 x from the right side. 1/2 x from the left side cancels down into just 0, so it completely disappears. And what is 5/2 minus 1/2? Just subtract your top numbers. Your denominator is the same. So just subtract your top numbers. You are left with 4 over 2x. And what is 4 over 2x? What is 4 over 2? It's another way of writing 2. So 2x and minus 10. And on the left side, we have 8 equals all of that 2x minus 10. Just to kind of give you some arrows. So we subtracted the negative 1/2, or we took away 1/2 x. We were left with 4/2 x, and that is another way of writing 2. We simplified to a 2. Okay. Now we want to get rid of the number that's a little bit farther away. We want to isolate the variable, get everything else out of the way, and we're going to start with that minus 10, right? So how do we move a minus 10 over? What's the opposite? What's the inverse operation of minus 10? It is plus 10. So we're going to add the 10, or we're going to add the 10 to both sides. Okay? So what is 8 plus 10? Nice and easy. We have 18, and that equals 2x. And what happens to our minus 10 and our plus 10? They cancel out into a 0. We don't need to write that again. So 18 equals 2x. How do we get rid of that coefficient, or how do we isolate this variable? The inverse operation, you divide both sides by 2. Because you have to maintain the equality over the equal sign. Whatever you do to one side, you must do to the other. Divide that down. That simplifies into a 1. 18 divided by 2. We're left with 9. And that equals x. And just for the sake of keeping our variables first, we will say x equals 9. And just like all of the other examples, we're going to circle our answer. So, not too bad, right? Pretty nice and easy way of solving one variable linear equations. So now I just want to take a moment and just tell you to take a deep breath, because we're going to open up our word problem, right? Like on this screen, when I open up this word problem, it's going to basically fill the screen. And I apologize for that. But we are going to go through the word problem, so you have a little bit of time to process everything. I'll tell you what's important and what's not important, and then we will go ahead and solve the word problem. So it's very similar to what we have been doing. I'll say that. So the end result is we're going to do something similar to this, but there's just words involved at first. But the work is the same, so don't worry about the word problem. So let's clear all of this out, and it's time to get the word problem up there. Let's go. Oh man, I'm so sorry. Don't worry, don't freak out. Don't freak out. Each month, John earns $1,200 in salary, plus an 8% commission on sales. The equation T equals 1,200 plus 0.08 S represents John's total earnings each month. In July, John earned a total T of $2,800. What was the value of John's sales in July? So I'll say, the majority of this question, you don't need it. There's a lot of extra information in here. Math, even your word problems, can be boiled down to just your expressions, your equations, different types of operations, right? So all of this stuff here, like, it's added information, okay? It's just them telling you the details, but it's not what's really important. So here, right here, we say the equation T equals 1,200 plus 0.08. S represents John's total earnings. This is important. This is what is telling us the total earnings each month. So we need this equation, okay? We're going to use this equation. And then what they're telling us down here is that he had a total earnings of T equals 2,800. So this is another very important piece of information. T equals $2,800. That's his total earnings for the month of July. Those are the only two bits that are really important. And then, of course, they ask you, it's another way of saying solve the equation for S, right? So if we have T in our equation up here, the one thing we don't have is the S, right? Is that okay? I hope it's okay. I hope you understand that a little bit. A lot of the junk in your word problems, not important. So always try to decipher it. Try to read through it, calm yourself down, go nice and slow, and read through your word problems and get rid of what you don't need. So in reality, what this word problem is this. Much nicer. T equals 1,200 plus 0.08 S. and t equals $2,800. So all we have to do is solve. We're going to solve. Where's my cursor? Oh, there. Uh-oh. Okay. So we're going to solve for S. They don't tell us that, but in the word problem they kind of did, but solve for S. So this right here. And we can rewrite the equation, our t equals equation, as $2,800 equals $1,200 plus 0.08 S. Okay? Then it's just like your other equations. It's just like all of the other examples that we've done. We need to isolate the variable. We need to get S by itself. So, how do we do that? We subtract the $1,200 from the right side, and whatever you do to one side of the equal sign, you must do to the other side. So go ahead and subtract the $1,200 from the left side, and we are left with, so what is $2,800 minus $1,200? We are left with $1,600. And that equals our 0.08 S. Not too bad. Now, most likely, when you take the GED or any of your other exams, they're going to give you some type of calculator. But the process, the steps, that's what you need to remember. So how do we get rid of the 0.08? How do we isolate the S? How do we get the S by itself? We divide. We divide both sides by 0.08. 0.08. Okay. What happens to this right side? It cancels out. It simplifies down into a 1. And what we're left with, let me pull out my calculator because I can't do this in my head. So, 1 second. What is 1,600 divided by 0.08? We get 1,600 divided by 0.08. We are left with 20,000. So $20,000. So on the left side, it is, it is S, or not S, sorry, $20,000, and that equals your S. So this comes up here, that's what it is, and you can just flip it all around and say S equals $20,000. That is your answer. That is the solution to this problem. That's how much sales John did in the month of July, and this was his pay. The $2,800 was his pay because of his 8% commission. Okay, so you can figure this out, right? Like if you work in a sales job and you know what your percent commission is, you can figure out how much you're going to get paid. If you have a base salary, right? It's very, very useful. Good. Well, it's useful in the sense of, well, what if your boss isn't paying you the right amount of money? You can always double check their math, and I highly and strongly encourage you to check your employer's math, because if you don't like doing math, they most likely don't like doing math, and this math matters because it's how much money you're getting paid. So it's very important to check your boss's math. Thankfully, I haven't ran into too many problems with that. But that is it. That is it for our one variable linear equations. And now we're going to move on to two variable linear equations. Okay, this gets a little bit more complex, but it's still the same, roughly the same idea. We're going to get back to the exact same process that we've just been covering. So you have two, I know, boom, I hit you with a lot, okay? You have two variable linear equations, also known as a system of equations. That's what that looks like up there. I do have a graph, which I'll explain, but I want to take a second and tell you, if you haven't hit the like button, please hit the like button. It spreads it. It spreads my video. So if there are other people out there that need help with math and need help with the GED, you hitting that like button is spreading it, right? It's getting the message out there a little bit more. Okay. So before we get into the deep dive, the meat of two variable linear equations, I want you to kind of help process. I want to help you process what this means, okay? So what is this part of the title? Whoops. Two variables. Two variable. What does that mean? Two variables, right? So there you have two different unknowns. You have an x in this example, and you have a y. These are your two variables, right? In this entire thing, you only have an x and a y. They're two variables. It doesn't matter that we have this other equation, because the x's have to be the same and the y's have to be the same. They're just placeholders, right? That's what a variable is. But if I made the statement that 3 is x, that means that 3 is x in both of these x's. Okay? Now, what does linear mean? What do you think of when you hear the word linear? It's line, right? That's why I drew these. So we have our two lines. So each one of these equations represents a line. Doesn't matter if it's like this or like this, but it has to be a straight line, okay? That's the part that's very important to this. It must be a straight line. But it doesn't matter which way it's going. These equations will tell you which way it's going. And later on in the future, we will go over graphing linear equations. Not today. But I wanted to give you an idea. So this is line 1, and this is line 2. We have two equations in our system. So to give you an idea of what the graph might look like, I'm not guaranteeing that this is what it looks like, but it is definitely two lines, and they intersect at a point, and that point is what we're trying to figure out. We're trying to figure out the answer to this system of equations, and the answer to a system of equations is where the lines intersect. So to think about it, if we had 3 equations up on the board, how many lines would be on our graph? If we had 3 equations, most likely we would have 3 lines. Not all of the time, and someday when we get to that part, we'll go through it, but it's kind of easy to remember. You know, if you have 3 equations, you're most likely going to have 3 lines. If you have 4 equations, you're most likely going to have 4 lines. There are some exceptions to this, but don't worry about the exceptions yet, okay? But system of equations, 2 variable linear equations. I hope just going through that has helped you out a little bit on understanding what we're going to be doing, okay? Before I move into the next slide, I will say there are 2 methods of solving 2 variable linear equations. There are 2 ways to solve these equations, and I'm going to go through both ways. I'm going to give about 2 examples of each way of how to solve them, okay? So let's get started. Our first method of solving these equations is through a process called substitution. So words, I know I'm hitting you with a lot of words. The substitution method of solving a system of equations. I'll go through this, don't stress. One of the equations is solved for one variable, then used to solve for the other variable, okay? Not too difficult. So you have one variable or one equation. We're going to change the way that one equation looks to where it's like either x equals or y equals or whatever letter they are having you use, and you're going to set it equal to the other side, right? So x equals a bunch of junk, y equals a bunch of junk. And then you're going to take that equation and plug it into your other one and solve. So let's go ahead and take a look at our example problem. And right there. Okay. So substitution method. This is our first example of substitution method, just so you can get this kind of down in your head and you can feel a little bit more comfortable with what I mean by substitution method. Just to kind of get your brain going, what does substitution mean? What's a substitute teacher? What does it mean to sub in? If you're working and you want to take a day off, and your employer says, oh, you have to find someone to fill in for you. You have to find a substitute, right? So that's how we're going to kind of do this. We're going to substitute in one of our equations, and we're going to put it into the other one, okay? So what I see, remember, we're going to solve this to where it's either x equals or y equals. So what I see right away is that I have a negative coefficient on that very first equation. So I have the minus 2y. I have this minus 2y right here. And that makes it a lot easier to deal with. So what we're going to do is we're going to manipulate that equation. But before I do that, I'm going to move things out of the way just so we have a little bit more room. Okay, so let's go ahead. Oh, I can delete that a lot easier. Let's go ahead and just delete this. Boom, beep, bop, boom. We're going to delete the words, and then we're going to move everything up. No, there. And move up. Okay. Then I'm going to rewrite this top equation to where it's x minus 2y equals negative 4, and we want this equation to look like, x equals something. Okay, so how do we get the x by itself? Well, how do we isolate the x? What's happening to the x? 2y is being subtracted from the x. So what's the opposite? What's the inverse operation of 2y? Minus 2y? Well, you add 2y. And you have to do that to both sides. Whatever you do to one side, you must do to the other. So we are left with x equals, and we can put our variable first of 2y and minus 4. So this is our new equation, and notice it's x equals something, right? Well, what do we have in this second equation? We have x plus y equals 20. And what are we saying x is? X is this junk. X is 2y minus 4. So we can plug in the 2y minus 4 for the x. They are the same thing. I'm making that statement. They are the same, okay? So let's go ahead and just do that. Let's replace this. So we have 2y minus 4, and we have plus y equals 20. Notice this is the same equation, but I have rewritten our y, or our x, sorry. I've rewritten our x as 2y minus 4. Now, you combine like terms. You simplify everything. So you have 2y and a plus y. So how many y's do you have? You have 3y minus 4 equals 20. And look at that. We're back to our normal comfort level, right? We've been doing examples like this the entire class, so it's the same process. How do we... Did I do everything right? Let me double check my math. Yeah, yep, we're good. We're good. Everything is good. We're perfectly fine. So, what do? We go ahead and we want to isolate the y by itself, so we add 4 to the left side. Whatever you do to the left side, you must do to the right. So you add 4 over to the right side. Your left side, the 4's cancel out into a 0. Go ahead and rewrite your problem of 3y equals, and that falls away, goes to 0, it doesn't matter anymore. 20 plus 4, what is 20 plus 4? It is 24. We have 3y equals 24. How do we get the y by itself? What's happening between the 3 and the y? It's multiplication. So what's the inverse of 3 times y? Well, you have to divide by the 3. Do that to both sides of your equation. Your 3's simplify down into a 1. You're left with y equals, and what is 24 divided by 3? 8. You're left with 8. But we're not done yet now. We still have to figure out what x equals. So check this out. I'll use blue for this one. So what we can do is take this y equals 8 and plug it back in to our x plus y equals 20. Rewrite the problem as x plus 8 equals 20. And then we move that 8 over, so we subtract 8 from both sides. Oops. And we're left with x equals, and what is 20 minus 8? It is 12. Go ahead, always circle your answers. X equals 12, y equals 8, and remember, this is a point on a graph. So another way of answering this is as point form. So your first number in point form is your x value, so it's 12, and your second number in point form is 8. So this is another way of writing this answer, and in my opinion, this is the best way to write this answer. This is an awesome way to write this answer. Okay. I hope that helps you out with substitution. Think about what we did there. We took our equation, changed it around a little bit, and then substituted it back in. Okay. All right, let's go ahead. And so remember, I told you there's 2 different ways to solve. There are 2 different ways to solve a system of equations. We just covered the substitution method. The second method is called linear combination or elimination method. Just giving you a warning, I'm going to put a lot more words up on the board, so I want you to be visually and mentally prepared for a lot of words. Boom. Okay. Whew. Calm her down. Don't get too excited. Definition: linear combination method, also known as the elimination method. One or both of the equations is multiplied by a constant to produce new coefficients that are opposites, so that one variable may be canceled out. Hang on, I have to sneeze, and I don't want to sneeze in your guys' ears if you're listening. Nope, now that I said it, I don't have to sneeze, so that's kind of cool. Okay, let's go through this. The main ideas here. Ooh, I do have to sneeze. Man, this is like, it's teasing me. It's just teasing me. Gosh darn nose. Okay. So linear combination. So line. Linear is line. Oh, I wasn't successful. Sorry, guys. It's a line still. We're dealing with lines. Combination. What do you do when you combine things? You put them together. Linear combination method. Okay. But it's also known as the elimination method. The reason why is right here, the canceled out part, right? So you have to combine your 2 equations where one of them cancels out. So that's why it's also known as the elimination method. But linear combination or the elimination method of solving a system of equations. Kind of cool. Sounds fancy, you know, but it's not too bad. It's not too bad, I promise. It's one of my favorite ways. It's one of my favorite ways of solving systems of equations. But the best way to get this down in your head is to see examples, to do examples, and I really encourage you to go out there and find examples of these problems. I use a website called Math Aids. I know it's a crazy name for a website, but it's helpful. Math help, right? You can go on there and you can find systems of equations for you to do to practice this. Okay. Let's go ahead and see our first example. All right, we're going to work through our first example of linear combination and the elimination method. So we have our system. It's still kind of the same business. This is a system of equations. It still represents the same thing or similar thing where it's two lines on a graph and they're intersecting, like they are touching. What's the only time that two lines on a graph they're not touching? It's when they're parallel, right? So when you are asked to find the solution to your systems of equations, either they are connecting at one point or they are parallel and there is no answer. So it is possible for your answer to a problem to be there is no answer. But in our examples today, we don't run into that. Okay. Now I see that we have what I'm looking at, how I'm working this problem in my head right now. I see the coefficients. I'm looking at the numbers in front of the letters, right? And what number is in front of our x here? It's called an implied 1. There's an imaginary 1 there. We're just not writing it down, nor are we going to write it down. Okay. Why is that important? Why is that important? Because we want to multiply one of these equations by a constant to eliminate one of the other variables, right? So what I'm going to do is I'm going to put this whole thing into parentheses. And then I'm going to put a -2 here. Okay? So what happens when we multiply, when we distribute our -2 through the parentheses? What is a -2 times an x? -2x. Okay? Then what is a -2 times 3y? What is a -2 times 3? It is a -6. And then don't forget your y. And that equals -2 times 1 is -2. So now we've successfully changed our equation. And the reason why we did it that way is when you look at this, so this is where that linear combination comes into play. The combination part to our title. So combination. Combination nation. So we need to combine these two equations. So you do the squish method. I like to call it the squish method. So you're going to squish everything down. You're going to add it all down. So what is a -2x plus 2x? 0. Gets canceled out into a 0. What is a -6y plus 2y? It is 4y. And that equals, what is a -2 plus 6? That is 4. How do we get rid of the 4 in front of the y? Inverse operation of dividing by 4. And we're left with the result of y equals, what is 4 divided by 4? It is 1. Circle that answer. We're good. We're done with that half of the problem. Okay? So now what we need to do, and I'm going to go ahead and I'm just going to circle this again in a different color just so we can get a little bit more deviation from everything else going on. We want to go back in and plug this in to one of these two equations. Whichever one you want, but I'm going to pick that top one. I think that one looks the nicest because it's just the x is by itself, right? So we have the original equations, not the modified ones. So we have x plus 3 And then our y gets replaced by a 1. And that equals, what does it equal? It equals 1. So 3 times 1 is just 3. So we have x plus 3 equals 1. How do we get the x by itself? What is the opposite of adding 3? You must subtract 3 from both sides. X equals, what is 1 minus 3? You have $1. And I'm coming up to you and I'm saying, hey, Joe or John or Shauna or Danny, whoever, you owe me $3. You have $1. And I'm saying, you owe me $3. Okay? What does that mean? It means that you have to give me your $1. So you have 0, and you still owe me 2. You're in the hole. You're at -2. Okay? But now we have our 2 points. Our 2 parts to our 1 point, sorry. So we have our 2 points. We have our x and our y. And we can write that in point form. So our answer to this, put it in parentheses. Your x goes first, so -2, comma. Put your second answer here, so it's -2 and 1. Your y goes second. And your answer to this system of equations is the point -2 and 1. So these two original equations intersected at the point -2 and 1. Not too bad, right? We're moving along. We're doing awesome today, guys. And I appreciate all of you for watching this. We're not done yet. I still have 2 more examples, right? Okay. But if you haven't already, I know I'm a repeating machine. But hit the like button, comment, subscribe. I greatly appreciate it a ton, right? Because that will make this channel grow. Okay, so we'll call it good there with me trying to get you to do that. But let's move on to our next example. So we have elimination method, example number 2. So we're going to do that exact same process that we just did. So we want to manipulate one of these 2 equations. And you want to be able to identify which one is the easiest so you don't get hit too hard. Okay? You don't want to make this harder on yourself. What I see, right? What I am seeing is, what can I multiply one of these equations by that after I add them together, it eliminates one of the equations? Well, check this out. We can multiply this second equation by 2, right? Because then we'll get a -4x. What happens when you have the 4x plus a -4x? It disappears. So that's why I'm going to do that. We distribute the 2 through, all the way through. All the way through. The entire equation has to be multiplied by 2. So 2 times a -2x, that is -4x. 2 times 5y, that is a +10y, equals 2 times 11 is 22. Rewrite our other problem. And we add everything down. Squish it down, guys and gals. Squish everything down. This cancels out. What is 10y minus 3y? 10y minus 3y is 7y. That equals 22 minus 1 is 21. How do you get rid of the multiplication that's occurring between your 7 and your y? You divide both sides by 7. And your 7's simplify down into a 1. 21 divided by 7, you are left with y equals, what is 21 divided by 7? It is 3. Boom. Boom. We got it. Okay? What do? Take this, bring it back in, and plug it into one of your equations. We're going to do that top equation. So we have 4x minus 3, and then parentheses, replace your y, replace this y with the 3. And that equals -1. So what is 3 times 3? It is 9. So we'll rewrite this as 4x minus 9 equals -1. How do we get rid of the the minus 9? What's the opposite of minusing 9? You add 9 to both sides. You have 4x, because this cancels out, equals -1 plus 9 is 8. Okay, so now we have 4x equals 8. How do we get rid of the 4? Divide both sides by 4. X equals 8 divided by 4 is 2. So our answer to this problem, we'll put it in point form. We have the x value of 2, which is your first number, and the y value of 3, which is your second number. And that is the solution. That is where these two lines intersect, is the point 2, 3. So boom, we know where it landed. We know where it hit. The two lines crossed at 2 and 3. Okay, now we will move on to another example of the substitution method. So we have 3x minus y equals 10. Okay, 3x minus y equals 10. 2x plus y equals 5. Substitution method. I know you might be thinking, Paul, why don't we just use the elimination method? That's because I want you to get that substitution method in your head again, right? What you might be seeing is that we can just squish this down right now. Boom, squish it down. -y and a plus y. So this is where it comes in handy, because if you don't see these things, you have to be able to still work these problems the best that you can, right? So we're going to do this with substitution method, although it would be easier, much easier, to do the elimination method. But let's go ahead and do this. So we want one of these equations to equal either as an x equals something or a y equals something. We want to move things around. We want to use our algebra skills to move everything around. So 3x minus y equals 10, or the 2x plus y equals 5. Let's do this second equation. We're going to rearrange things. So how do we make this equation as a y equals problem? Well, we are going to move the entire expression, the whole thing, of 2x over to the other side. So how do we move this? I'll use a different color. How do we move this over here? What is happening to it? How do we get rid of it? Well, we have to subtract 2x from the left side, and we're going to subtract 2x from the right side. We have y equals, so this cancels out. We have y equals, and then what I'm going to do is I'm going to write the expression first. Minus 2x. Is this a positive or a -5? It's a positive 5. So positive 5. Okay. So we have -2x plus 5. Y equals that. Now we're going to take this and plug it back into our first equation. I know it's crazy stuff. So it is 3. I'm going to write over here. We have 3x minus, and then we're going to take this and we're going to plug it in right here. Okay, because that is y. So this is like the current. If it's a river system, this is like the current here. Why I'm doing these things. Okay. So it's a -2x. This is all in parentheses. -2x plus 5. End parentheses, and that equals 10. Okay. Now we have this minus sign out there. What we can do is distribute the minus sign throughout. Okay, so distribute your minus sign. What is a negative times a negative? What's a -1 times a -2? You have an even number of minus signs. You have an even number of negative signs, so they cancel each other out, right? I'll start rewriting this, and I want you to just kind of take your time. If you have to, pause, right? So 3x negative times a negative is a positive 2x. Negative times a positive 5 is a negative 5, and that equals 10. What is 3x plus 2x? 5x minus 5 equals 10. How do we get rid of the minus 5? We add 5. Okay, how do we get rid of... Oh, let me rewrite this. Sorry, I'm getting ahead of myself. So we have 5x equals 15. Divide both sides by 5. That cancels or simplifies down into a 1. X equals 3. Go ahead. We're going to use this top equation. We're going to replace the x with 3. Minus y equals 10. So you have 3 times 3. Okay. And what is 3 times 3? It is 9. Minus y equals 10. How do we get rid of the positive 9? What's the opposite of a positive 9? It is a negative 9. So do that to both sides. Negative y. I know I'm way down at the bottom. Let me write this a little bit bigger though. Negative y equals 1. How do we get rid of this negative sign though? Divide by a negative 1. Both sides. We're left with y equals negative 1. So our end answer is x equals 3, y equals negative 1. Let's write that out in point form. So we have 3 and negative 1. Oh, let's make that a little bit neater. Go ahead and circle your answer. And there you go. You have answered our substitution method example number 2. And at this time, I'll say one last time, if this video has helped you out, make sure you hit the like button. If you aren't already subscribed, subscribe to my channel. I'm putting out tons of content for the GED, but it also just helps you learn different things, right? Even if you already have your high school degree or your GED, this will just help you improve your math skills. So go ahead, subscribe. Otherwise, I appreciate all of your time. I appreciate you watching the class today, and I hope you have a beautiful day. And if you are coming back again, my class is tomorrow at 9 a.m. I hope you have a good day. I appreciate you.